How does an AI know that king and queen mean almost the same thing? It buried a map. Follow the directions, and you dig up queen. Welcome to ThirdEye Labs, where we make the unseen seen. Today, how AI turns words into arrows. Remember the last season. A vector is an arrow, and an arrow is just a list of numbers. So turn a word into a list, and the word becomes a point in space. Pick two features: how much action, how much romance. Now each feature is an axis. An action film lands far along action, low on romance. A rom-com, the opposite. Every movie is now a single point, two numbers, one place. A movie is just a few dials. How much action, how much romance. Set the dials and you have placed it in space. Do this for thousands of words, and a real map appears. Words that mean similar things drift into the same neighborhood, and that gives the core move of AI. Pick any word, and its nearest points are its closest matches in meaning. Two songs on the same playlist sit near each other. Close together means similar. That is the whole idea. But who decides where a word goes? No human does. Here is the trick. A word is known by the company it keeps. Cat and dog both fit these blanks. They keep the same company, so the model nudges them together. Read billions of sentences, and meaning arranges itself, no labels needed. So how do the vectors land in the right place? Slide a window over real text. For the middle word, the model tries to guess its neighbors. Every time it guesses wrong, it nudges that word's vector a little. Words that share neighbors get pulled together, like a spring. Unrelated words get pushed apart. Billions of nudges later, meaning has arranged itself, with no labels at all. This idea is old. In 1957, the linguist Firth put it in one line: "You shall know a word by the company it keeps." Decades later, in 2013, a team at Google turned it into an algorithm called Word2Vec, and the king-queen magic fell right out of the numbers. Here is the moment that stunned researchers. Place man, king, and woman. The arrow from man to king is a direction. Call it royalty, what you add to a person to make them a monarch. Now take that exact same arrow and start it at woman. Where does it land? On queen. King minus man plus woman equals queen. Meaning became arithmetic. The arrow from man to king is the very same arrow from woman to queen. The direction itself means royalty. Let us actually do the arithmetic. Pretend each word is just three numbers: how royal, how male, and so on. King minus man plus woman, one coordinate at a time. 0.9 minus 0.2 plus 0.2 is 0.9. Down the line, 0.1, then 0.4. Put them together and you get 0.9, 0.1, 0.4. That is queen's vector exactly. The analogy is real arithmetic. Here is a real sentence. Inside the model, that one word, king, is this arrow, and this little list of numbers. Now change exactly one word. King becomes queen. The sentence changed one idea, and exactly one direction moved. Royalty held still, gender swung across. That direction is meaning. Real models pick it up from the words around it. That trick is attention in Season 5. And king and queen is no fluke. Take France to its capital, Paris. That arrow is the capital of direction. Start it at Italy, and it lands on Rome. The same works for verb tenses, for comparatives, for plurals. One direction, one kind of meaning, everywhere in the space. How do we measure close? With the angle between the arrows from last season. King and queen point almost the same way. A tiny angle, so a cosine near one. Very similar. King and banana, a wide angle, a cosine near 0. That single number, cosine similarity, is exactly how search and recommendations rank what is closest to you. Two axes were just to picture it. Real embeddings use hundreds of axes at once. Royal, animal, formal, and features no human ever named. Stack those values, and you have the word's vector. The bars are the list of numbers. You cannot draw 300 dimensions, but the math does not care. Each word is still just one list. Trust the list, not the picture. A dating profile has dozens of sliders. You cannot draw that, but it is still just one point in a space with dozens of axes. And it is not just words. Images, songs, users, even you. AI turns every one of them into a vector first. Once everything is a point in the same space, finding similar things is just finding nearby points. That single trick powers search, recommendations, and every vector database. And it is not only words. A photo becomes a vector. A whole sentence becomes a vector. They can share the very same space. Put pictures and text in one space, and a matching photo and caption land right next to each other. That is how you search images with words. The model behind it is called CLIP. Here is how a chatbot actually looks something up. Scatter every document as a vector. Turn your question into a vector too. Find the few document vectors nearest to it, and hand just those to the model to read. That is retrieval, the engine behind modern AI search and RAG. One honest catch. The word bank means a riverside and a place for money. A single fixed vector has to blur both into one blurry point. Modern models fix this. They read the words around it and give bank a different vector in each sentence. Riverside flies one way, money the other. That context trick is called attention, and it is exactly where this whole story is heading. And you can run this yourself in 3 lines. Load some pre-trained word vectors. Subtract man, add woman to king. Ask for the nearest point, and out comes queen. The lab builds exactly this. But here is the catch. The space learns whatever is in the text, including our prejudices. Early embeddings answered, doctor minus man plus woman nurse, programmer homemaker. The geometry had quietly absorbed society's stereotypes. A mirror this powerful reflects the ugly parts too, which is why researchers now measure that bias and correct for it. One honest word. The arithmetic is a strong tendency, not a law. It works beautifully for famous pairs, and it quietly misses on rarer or messier ones. It is a learned approximation, not a perfect machine. Useful and honest about its limits. People call embeddings magic. They are not. An embedding is just a list of coordinates a model learned, tuned so that distance means similarity and direction means meaning. No magic. Just geometry that was trained. In one breath, turn a thing into a list of numbers and it becomes a point. Close points mean similar things. Directions carry meaning, so king minus man plus woman lands on queen. Real spaces have hundreds of dimensions, and AI turns everything into vectors first. Meaning is geometry. Next, watch a single matrix bend all of space at once. That is what one layer of a neural network really does. Thanks for watching and keep exploring. Next time, matrices as transformations. Please like and subscribe ThirdEye Labs if you enjoyed this video and let me know in the comments.